Okay, let's talk about the forearm extensor muscles. We're going to identify those four forearm extensor muscles and talk about their primary actions and the innervations, and also discuss the anatomical snuff box. Okay, so to start, there are 12 forearm extensor muscles. I know these muscles, and I look at this list and it makes me kind of scary, but it's kind of cool how they make a little triangle down, doesn't it? But if we take these 12 muscles and now let's organize them in a fashion to recognize there's actually some pattern to how we can help learn these 12 muscles. First, 3 of these muscles all are going to act on the carpi bones. And so there's 3 carpi muscles. 3 of these muscles are going to go to the pollicis, or your thumb. So 3 carpi, 3 thumb, and 3 digit muscles. So they're going to do something with the digits. And then 3 others that do something else. And the primary one we're focusing on, brachioradialis, supinator, and coneus, we'll just talk about to be complete. So let's take a look at first the 3 carpi muscles. Notice they say extensor carpi in them. There are any of these muscles on the back of the forearm, for the most part, they're extensors. And then they tell you where they attach, the carpus, and it's either on the radial or ulnar side. So let's look at the extensor carpi radialis muscles. They arise from the lateral epicondyle, and this one goes down to the base of the second metacarpal. And it's long because its cousin is the extensor carpi radialis brevis that also comes from the lateral epicondyle but farther down, and it goes to the base of the third metacarpal. So one's long and one's short, hence extensor carpi radialis longus, extensor carpi radialis brevis. Now the extensor carpi ulnaris arises from this lateral epicondyle, and it goes down to the base of the fifth metacarpal as well. So when we look at these 3 muscles, extensor carpi radialis, extensor carpi radialis longus and brevis, and then the extensor carpi ulnaris, these 3 muscles together are going to extend the wrist from here to here, wrist extension. All right, now let's take a look at the 3 pollicis muscles. And these, whenever you see again this word pollicis, think thumb. And these muscles will abduct the thumb or extend the thumb. So let's take a look at the abductor pollicis longus first. We'll do that. Let's take these superficial muscles and cut them out of the way because we got to go deeper down. There, we're at it now. Okay, so the abductor pollicis longus, it comes from the radius and goes to the base of the first metacarpal, your thumb metacarpal. When this muscle contracts, it does that action. Abduction, pulls the thumb away. Then we have the extensor pollicis brevis that really goes from the radius and interosseous membrane to the proximal phalanx. And then the extensor pollicis longus that comes from the ulna and goes to the distal phalanx. So when we look at these 2 muscles together, their primary action is, as their name says, extend the pollicis, extend the thumb in that manner. Thumb extension from here to there. Okay, so there we've got our 3 pollicis muscles. Now let's take a look at our 3 digit muscles, and they're going to extend the digits in some way. Let's look at the most significant one, the extensor digitorum communis. We're going to go back to the superficial view, and there's our extensor digitorum communis. It arises from the lateral epicondyle, courses down, and then bam, there are 4 tendons that shoot off, and they form a community that go down to the distal phalanx of the digits 2 through 5. They attach to something called the extensor expansion hood on the back of these digits, and I'll talk more about that in the hand. EDC for short. And so even though these muscles will extend the wrist because they're primary wrist extenders, they're also the principal extender of the MCP, your metacarpal phalangeal joint. And so when you take a look, there's our metacarpal phalangeal joint. So that movement is extension from here to here. And the extensor digitorum communis primarily extends that joint. The IP joint extension is primarily done by the lumbrical muscles. So make note of that. This is going to become a significant feature when you start dealing with all those claw hands that you guys are studying for boards on. So remember that. Lumbricals will extend the IP joints. Extensor digiti minimi goes to the minimum digit, your pinky. Goes from the lateral epicondyle all the way down to your pinky and extends it. So extensor indices, it comes from the ulna and it goes to the distal phalanx of your index finger, hence the name extensor indices. And so your index and pinky have an extra extender. So in that way, when we now take a look at this picture, it's a picture of a right hand, and you're going to do the rock on symbol like you see at rock concerts all the time. There we have rock on. And the reason why you can do this quite easily is that your index and pinky finger, in addition to the EDC tendons, have an additional tendon. So index finger has EDC and extensor indicis muscle. Your pinky has the EDC and the extensor digiti minimi muscle, or their tendons. Whereas to do this movement, it's a little bit more difficult because if you're trying to extend just your swear and ring finger, there's only the EDC tendons that do that. And that's why it makes it a bit more difficult. Okay, so now we've done those 3 digits. We've done 9. So we go to the 3 others and the focus on that brachioradialis. So there we've got an anterior and posterior view of the brachioradialis on the right side. Brachioradialis comes from the lateral supracondylar ridge, and it courses along the front of the elbow. And so what makes this one unique is that the brachioradialis is considered a forearm extensor, but caveat, star, happy face, something, brachioradialis flexes the elbow. So it's the exception to this. It's innervated by radial nerve and so forth, considered part of the forearm extensor muscle group and posterior forearm muscles, but it flexes the elbow. The supinator supinates, and it's pierced by the radial nerve as it goes in the forearm. And the anconeus basically attaches to the olecranon process of the ulna and assists the trapezius in extending the elbow, but don't care if you know it. So what are some things in common that these forearm extensor muscles have? Common location, they're posterior forearm. They're located on the back of the forearm, hence forearm extensors are posteriorly located. Their common origin, many of these muscles arise from the lateral epicondyle of the humerus, whereas the forearm flexors are the medial epicondyle of the humerus. Their common action, extension, hence forearm extensor muscles. So muscles on the back of the forearm primarily extend, wrist and so forth, and MCP, thumb, and that. And the common innervation, all of them are innervated by the radial nerve. That's what makes it so nice. As soon as the radial nerve comes through the supinator and enters the posterior forearm, shing, it's going to innervate all those posterior forearm muscles. All right, now a kind of a cool regional thing is the anatomical snuff box. And we take a look at this right hand, and in orange there are some specific tendons, the abductor pollicis longus, extensor pollicis brevis, and extensor pollicis longus. And if we go distal to the extensor retinaculum, there we've got our anatomical snuff box, that little region. And within the anatomical snuff box are the following things. One, the scaphoid bone. I'm pointing it to air there because when I drew this in grad school, I never finished this picture. So sorry, I'm pointing in there, but the scaphoid bone, one of the carpal bones, forms the floor of the anatomical snuff box. And then we have an artery that courses in the forearm right through the floor of the anatomical snuff box, and that's our radial artery. So there's another place to find, another thing that's significant is then superficial to the scaphoid bone is our radial artery. And then over the roof of the anatomical snuff box is a nerve, and it's the superficial radial nerve that does innervation to the back of the hand. So though there are the boundaries and the contents of the anatomical snuff box. And so now if we look at a real hand, that's the location of the anatomical snuff box.